this is at 2020 for two C1 C2 concentric circle diameter of C1 is 2 centimeter longer than that of C2. Okay, so that should immediately tell me that the referencing radius is 1, which is half of the diameter. So C1 and C2 be concentric circles. So this is C1, or actually C1 may be bigger because C1 has a larger diameter. So this is C1. This is C2. This is center. So for example, if I take this as R, then this radius would be R plus 1, because half of diameter would be the difference. If the diameter difference is 2, this would be 1. If chord of C1 has a length of 6 centimeters, so chord of a bigger and is tangent to C2. Okay, so there's a chord of C1 which is tangent to C2, something like this, and the diameter of C1 is what? Okay, this seems like a pretty straightforward question, right? Like, if you see the bigger circle, you know that there's a chord which is tangent to this as well. So, and concentric means the same center. So again, our like go-to mechanism for a chord and a radius type of a setup, wherein you need to find one of those and the other is sort of given, is just drop a perpendicular from center to the radius, right? So in this triangle, if you see, this is the smaller radius, we know that this is R, this is a bigger radius, we know this is R plus 1. Perpendicular from center to radius bisects the chord, perpendicular center to chord, I'm sorry, bisects the chord. So if the chord has a length of 6, this is 3, you're done. R plus 1 whole square would be equal to R square plus 3 square. Again, it's clearly visible that these two are differing by 1. So this again seems like a 3 square plus 4 square equal to 5 square type of setup. So R will be 4. Is that our answer? No, because it's half the diameter of C1. So R plus 1 would be 5. This is the diameter of C. This is the radius of C1. The diameter of C1 would be 5 into 210. So once again, this reiterates that from a conceptual standpoint, CAT is not looking for fancy stuff. Fundamentals should be clear, and how fast you can approach the problem should be well set in place, which would come with practice and variety. But other than that, like CAT would expect like conceptual clarity rather than like hi-fi stuff. So pretty short question, right? Shouldn't take more than a minute in an exam type of a scenario. Done. Now, yes, now what we had discussed are the family of circles, right? So a few questions relating to that. So find the radius of the smaller circle if the bigger circle radius is 3 and ft is equal to 4. So the moment I see this diagram, the concept of similarity should immediately strike in my mind that okay, if the sort of question statistics or what is asked refers to side lengths, similarity should help me. Like at least I should start thinking on those lines of similar triangles, right? So basically, again, find the bigger circle radius is 3. So essentially, this is then 3. This is R. We saw before that these two and this point of intersection will lie in the same line. So to draw that, and FD is equal to 4, so which is this is equal to 4, right? So now we saw that this triangle will always be similar to this triangle. So if I was to mark the points as, let's say, P and Q, so it will always be that this triangle is similar to this triangle. So basically Fn by Fd, let me just write it directly. So let's write all the three ratios basically. So Fn by Fd will be equal to Fq by Fp. At this point, like I'm pretty sure this must have like started to occur naturally as well, how to write the ratios, and then would be equal to R by 3. And this is what needs to be found out. Fn by Fd, okay, I know is 4. Fq, do I know? I don't know. Fp, do I know? I don't know. Okay, so how to proceed now? It seems like generally what happens, right? So generally, if sides were known, then we would have either used like this equal to this or this equal to this to figure out R, as we have done in a previous question, right? That if one part of this we know completely, then we use that, and that's the way to go if those are known. But here those are not known. How? And that is where like you need to figure out from like what can you figure out additionally, right? So for example, Fn is this length. Can I figure this out directly? Is there something that I can use? Doesn't seem so. All that I know is that This is 3. This will also be 3. This is R. This will also be R. So PQ is something that I know, right? So basically, if we look at this part, FQ is still FQ, let's say, but FP will be nothing but FQ plus 3 plus R. Correct? Makes sense. This is the first catch. The second catch is the simpler catch actually is that this is 4, this is 3. I can find the total length of FP which is 5. This is a right triangle obviously, right? Center tangent, like radius tangent. So this is FD square plus 3 square, which is 4 square plus 3 square should be equal to this square. So FP is equal to 5. So essentially what I'm looking at here is that this is equal to 5. This I already know. So that is what, those are things I need to catch once I write this equation. That okay, is there a direct way to figure out some of these parameters? Now writing it is simpler because FQ I can just directly write as 5 minus 3 minus R upon 5 equal to R by 3. So what started from a system of like completely unknown sides is now an equation in one variable which is solvable. Right, so basically this is nothing, 5 minus 3 nothing but 2, so 6 minus 3R equal to 5R, so R equal to 3 over 4. This is the answer. So the purpose of this question was to see, it's a very simple solution, right? It won't take any time, but the purpose was to basically see that okay, once you have these side relations, and again similarity is useful in such cases, but again to figure out individual lengths you'll have to observe the figure carefully to see that okay, what can I fetch from this figure. 3 4 5 was a direct giveaway, should have struck. Then FQ, can I write it in terms of R because R is what I eventually need? Can I write it in terms of the total length 5 and the 3 that we know? Obviously we can. So we wrote it in those terms and this is it. So again, sometimes even before you start applying the concepts, right, sketching everything possible from the diagram also is a something that will come as you do more and more questions, and that is the purpose of covering a good number of questions in these sessions. Same thing, just that there's another circle here, and there's a specific reason for this. The concepts that we've learned in the theory, right, will hold true for every scenario. Like if there are like 10 circles, you can always like join those lines of the centers and establish similarity and take the ratios. No problem at all. The reason for putting in this question was to illustrate one small concept. Whenever you have more than 2 circles, right, then the circles will always, the radius of the circles will always be in a geometric progression. Remember this. For example, here the largest, if the smallest and the largest and 2 and 8, to say that okay, this is 2 and this is 8, the middle one will be 4. If you had 4 circles, for example something like this here, and the like again these circles should be like within the same common tangents basically. So if you have a common tangent here, you have a common tangent here, if they are bound within the same common tangent, then the radius will be in GP always. So if even if you're not given, for example in this case, if you were said that okay, the smallest is 3, radius is equal to 3, and the biggest circle has a radius of 81, and you had some question, so you should be immediately able to figure out that these radii will be in geometric progression. So basically this would be 9, this would be 27. So that's kind of the first reason to give this question, and second is to just again illustrate how to deal with these family of circles and use those ratios, right? So if the radius of smallest and largest are 2 and 8, so the middle will be 4. Find OP. So okay, as usual, as we do in all such questions, we will join the line of the center to the meeting point here. All these will be 90 90 90. You have to find OP here. Each of these will also be 90 90 90. Cool. So like similar drill, right? So for example, if we have M, let's say O is already being used, right? Let's use X here. Now I know this is 2, this will also be 2. This is 4, this is also be 4, this is also be 4. And it's like suggested for you to just basically mark these in the figure when you see this like 8 and then 8, so that there are more figures that you know. There are more numbers that you know inside that figure, so just to make it easier. So I know these things. Okay. So now if I see the smallest and the biggest one, like the smallest and the biggest triangle, right? Because OP, why am I taking the smallest and the biggest? Because OP is part of the smallest one only, right? And I need OP. So basically in these two triangles, I can write those like our favorite ratios basically, that OP by OR will be equal to OM by OX will be equal to R, or 2 actually, we know this radius, 2 over the bigger one which is 8, which is 1 by 4. Cool. So this we can figure out now. Now OP by OR, if we use as equal to 1 by 4, do we know OR? We don't know that. But like in our previous question, what did we do? We sort of used the fact that some of these are equivalent to the radiuses. So basically, if we see this OM by OX part, it is nothing but OM by OM plus 2 plus 4 plus 4 plus 8, which is like OM plus 18 equal to 1 by 4. Because my plan is to see if I had a direct way to figure out OR, it would have been over right then and there. So 1 by 4 I know. But my idea is to, now that I can't do that, so what I'll do instead is basically use these radii to figure out this length, because these are anyways proportional. So OM plus 18 would be OX. So here, from here I can find out OM. OM will be equal to 4 and 1, 3, so 6. So this I know, OM is 6. This I know is 2. OP I can figure out. Pythagoras correct. So root over 6 square minus 2 square. So root 32 would be the answer. So again, the solution itself is simple enough, but the thought process should be to get to those equations once again as we had done in the previous question, and to see that what lengths can be figured out. If these direct lengths cannot be figured out, then use the same proportionality, use a different branch of the proportionality. Use this and try to figure out if you can make off something here. Because once you get this, this also is a way that once you get this, then you can use direct Pythagoras to figure this OP out, which is asked. Hopefully now the family of circles questions you should be able to do, because they'll not ask beyond this in any case, right? So yeah, like in general, from a conceptual standpoint, nothing will go outside of what we are discussing for these topics. So maybe useful to practice more and more questions. As the more variety you will be acquainted with, the easier it is to figure out there, and the easier it is to like strike it there, right? Two circles P and Q, each of radius 2 centimeter, pass through each other centers. Yeah, this is a bad question. Slightly tricky, but only because the diagram is a bit hodgepodge, for lack of a better word, right? So there are two circles of radius 2 passing through each other. Okay, so no, so then that is not the correct way to draw the figures. They have to pass through each other's centers. Something of this circle. This is center to this. This is the center of this circle. So C1 and C2. Now radius, okay, each is 2 only. They intersect at a point at points A and B. Okay, so this is again, it looks like a common chord setup that we have discussed in our initial questions. However, there's a twist to this. A circle is drawn with diameter AB. So there is a third circle in the picture now, with based on diameter AB. So just for pictorial clarity, right, let's probably use a pen of a different color, maybe that would help. So there is this circle, diameter is AB, and so there are 3 circles now, right? One is this, the third is the blue one, which is this. They've also given names to that. So let's get back to the original listing. So they've also given the names to the circles, 2 circles P and Q, each of radius this. So okay, so let's say this is P, the original left circle, then this is Q, and the blue circle is R, as they're given. Right. What is the area of overlap in square centimeter between the circles R and P? So let's just first see, right? And this question again, they are relying on the fact that people would take time to comprehend the diagram, and so like yeah, because the method itself is not as tricky, but yeah, the diagrammatic part of it is a bit this thing that, yeah. So this is the R circle and this is the P circle. You need to find what is the overlap. So the R circle, if I was to just outline it once again, this is the R circle. This is the P circle, sorry. This is the P circle. And this is the R circle, the blue ink. So essentially what I am required to find out is only this area, like this area. This is what, right? P and R. This is what I need to find out. Again, a similar mechanism. This is the area, break it down into figures that we are comfortable with. Simple principle. I can clearly see that this AB is the diameter of R, of this blue circle. So this, if I need to find this area, this portion is a semicircle. Why? Because this is the diameter of R. So this will be a semicircle of R. So one portion is definitely a semicircle of R. Here, the remaining part, which is this one, is clearly a segment, because if you draw it separately, if we draw, this is a circle P, let's say. So if you only see the circle P of this, there's a chord AB going through it, and you're required to find this area. This we know is a segment. So semicircle of R plus a segment of P. Now the crucial point of this question is that if it was just a semicircle and a segment, it's okay, but they belong to different circles altogether. So okay, now once we have drawn the figure, let's just take like one step at a time and let's just try to like draw those sub figures of this to understand it better. Right. So for example, first we want to focus on semicircle of R. Cool. Now this is a semicircle of R. This part, sorry, this part is a blue ink with a semicircle of R. This is the diameter. Right. So if I was to just draw R basically here, okay. Now we know that the radius of each, and again, it again gets to the calculative part where you know the radius. You need to figure out the length of the common chord. We have done this before. So it's the same questions that we have done multiple times, just combined into a bigger problem in this case. Right. So for example, here the radius is 2, and like the ordinal circles have a radius of 2. This was C1. So basically, you need to, like, this is 2. This line segment would be 2 essentially. So if we were to draw this, and we need to find the length of AB. Why? Because the semicircle of that would be the diameter of R, and we can use pi R square by 2 for the area. So if I draw the circle P here, just the circle P, this is the chord, this is the center. I know this is 2, right? What else do I know here? Yeah. Obviously, I have to draw a perpendicular here, right? So this I know is 2, this I know is 2. How do I find the common chord? Anybody? Because this is just like a small portion of this figure, right? Just so that it's easier to grasp how to like do each part of it individually. So this is AB essentially. So if I am able to find out one part of this, I can just directly do the sort of the twice of it, and that should be done, right? So again, we have done this before, how to find the common chord for this. So obviously the point is given that it passes through each other's centers, right? So basically, where like this circle would end, this there'll be a point which is the center of the other circle here, because it passes through that center. This length I know, like if I was to complete it with the other circle, there will be something like this, right? This is 2, then this length is 2, this would be 1, so this is 1. Let me just repeat once again. I need to find this length so that I can get this length, and into 2 will give me this common chord, right? The key point of the given data is passed through each other's centers. Why is this important? Because that helps me to figure out that okay, that if I draw this length, basically wherever, like, there'll be a point which is the center of the other circle on the circumference, right? So this would point, let's say, the center of the other circle. So this entire thing would be the radius, which is 2. Half of that would be 1, right? So this is 1, this is 2, so this is root over of 3. This is root over of 3. I can find out AB, which is 2 root 3. This is the dia, so the radius is root 3. Semicircle of R would then be pi into root 3 square by 2, so which is 3 pi by 2. So one part is figured out. Over. Cool. Now segment of P. Let's again draw P. It will be the same figure actually. You just have to figure out this area, right? Because this area is corresponding to this area. So segment of P means this area. Segment is again, as we have repeated, that it's sector minus the triangle. How to find sector? Pi r square theta by 360. I know r, pi I obviously know. Theta is something to be figured out, but since we know the sides of this triangle, it's easy to figure out. This would be what? The cos of this is 1 by 2. So cos of this is 1 by 2, so the angle would be 60. Similarly, this would be 1 by 2, so 60, so 120. The angle of the sector. I know the area of the sector is pi into r square, r is 2. So 2 square theta by 360, so 120 by 360 is basically pi by 3. Not pi actually, just 1 by 3 minus area of the triangle. This triangle I know all three sides. I can find the triangle area, or I can just find this right triangle area, multiply it with 2. So it will be 2 into 1 by 2 into uh, this was 1 into root 3. Let me repeat it once again. This we need to find the segment because semicircle is done, and this area was the sum of the semicircle and this segment. So if we just draw a portion of it, and it is highly advisable that in a diagram, if you find in an exam scenario that the figure is getting complicated or there are like multiple areas of shaded and etc., it is always easier to break it down like this into a different figure and then solve it and then go back to the other one. So this is that segment. This is 1, this is 2. This was 1 because this is like 2 upon 2, half of 2. Right, this 2 is the radius, so root 3, entire thing is 2 root 3, radius is root 3, pi r square by 2 done. Segment, this sector angle is 60 because cos inverse of 1 over 2. So sector area would be pi r square 1 by 3 because 120 over 360 is 1 by 3. And then the area of the two triangles here, or this big triangle, which is 2 into area of this right triangle. So 2 into 1 into root 3. Basically this is 4 pi by 3 minus root 3, which is the segment of P area. So now I have both parts of it. This becomes 4 pi by 3 minus 2. So it becomes 17 pi by 6 minus root 3, and this is the answer. So good question in terms of area calculations. But yeah, this is the sort of the way to do it. Not to say that this should not mean that that is trickier in general, but that will have like a couple of questions in at an interval of every like 4 and 5 questions will be very doable, and then one question would be sort of a where you need to put some time there, right, like this one. But before this and after this, 3 or 4 questions would have been like, okay, like you would have been familiar with those concepts, and you would be able to sort of apply them more quickly. This one, the diagram itself was a bit iffy, so that's why it took a bit. But otherwise, the concepts are very directly applied, right? Semicircle, we know. Segment, we know. There's nothing new getting applied here. So that as an exam is not as tricky, but there'll be like one question out of every like 5, which is a sort of the differentiator. Okay. In the following diagram, length of AB. Okay, this is a reversing radius of the length of AB. Give the length of a particular chord. Now let's just do this at the end. But there was, it seems, one more question that remains to be done. Was in the had I read in the beginning, it seems. Now this was supposed to be a warm-up question, but since we sort of started at around 5 cents, I wait, so couldn't share it in the beginning. But this was supposed to be a warm-up question to just get you in the sort of the mood for this. So let's just do it. Vertices of a triangle are 0, 0, 0, 4, 0, and 3, 9. Area of the circle passing through these 3 points is what? Coordinates are given. What is the area of the circle? Clearly, this is a triangle. There is a circle, so there is some circumcircle being involved. That should be the first takeaway, even before like putting it pen to paper, right? So okay, so now if we see these vertices and if we just mark them right here, like in the xy plane, right? So this is one vertex 0, 0. This is the second vertex 4, 0. This is 3, 9. So this is a triangle. So okay, we know now what the triangle is. Area of the circle passing through these 3 points. So basically area of the circle, right? Only one formula is there for area and like circumcircle or touching those three vertices and stuff, which is basically radius of circle will be equal to ABC upon 4 into area of triangle, right? Now there is a method in coordinate geometry to find area of triangle when coordinates are given. We'll probably cover that tomorrow, but you don't even need to do that actually here. What you can directly just like should do basically is that use area, because one side is easy to find, right? 0 0 and 4 0, obviously you know the length is 4, and the height is easy to find as well because you know the y coordinate is the height. These two vertices are on the x axis, so here the y coordinate is 0. Y coordinate gives the height, right? So this would be 9. So area, I can find area from the coordinate formula as well, right? Even that's a considerable method, but why like take more time for something that is directly intuitive from there? The height is 9, the base is 4. So area would be equal to half into 4 into 9, which is 18. So I know this part. A, B, C, I know all three coordinates. I can figure out the distance. A, let's say, is 4. For example, this length is 4. The other length, let's say, between 4, 0 and 3, 9 would be what? 4 minus 3 whole square. This distance formula again. Plus 0 minus 9 whole square. So this is root over 82. And the third side would be 0, 0 and 3, 9. So this is just directly root 3 square plus 9 square, which is 81, and 9 is root 90. You know the three sides now. So 4 into 82 into 90, this is root over 4 into area, which is 18, right? So this would give you the circumradius, and the area pi into r square would give you the circle's area, which is what is asked in the question. Very direct, so that's why it was like a warm-up question. And yeah, the fact of the matter is this is a CAT 2020 slot 2 question. So again, pretty straightforward, right? Simple distance formulas, nothing too high-fi, and just the fact that area of circle passing through 3 points, circumcircle, and this formula needs to be known. That's it. So any doubts up till this point? Like how are you finding the questions? Like are they like very easy for you, or like very challenging, or like you are finding them good as per the concepts that were covered, or good in terms of the variety that is getting covered?
Intermediate level questions are there. Some of the questions are very nice and new concepts are there.
Okay. No, that helps, because see, considering that CAT will not never ask very challenging questions, right? Like basically the first thing that needs to be realized, and you'll see in a miscellaneous group side back, uh, people keep posting some hi-fi question, like not like always, but occasionally. Like let's say every day you will see like some 2 or 3 questions that people will start debating on, but that question will never appear in an exam like that, because it's not a math exam, it's a quant exam. There's a difference, right? So, but within that realm of CAT, we should definitely be prepared. And again, like should always be like 105% is better than 98%. And we'll have a small chat tomorrow about the exam itself as well. But 105% is always safer than 98% for quant. Right. So you don't need to do very difficult questions, but you should definitely do questions, because like once the solution is shown to you, right? For example, if I'm solving it right now, then it's easier to sort of collect that, okay, yes, this is getting used. But once you have to like figure out in a mock setup or in an exam setup that okay, like I have 2 minutes and time is running out, and how to figure out. So that's why like we are also focusing on a thought process a lot. And the main purpose of these questions is to not like get the answer, but to like basically have you strengthened on that fact to strike these questions faster in terms of thought process. And then of course theorems you would know. Right, so that is why, and this is very useful for quant specifically, like 105% is safer 98%, because quant generally you'll see in terms of CAT that that there'll be a range of scores which is very densely populated. Right, that So like a lot of people would be there in like a range of, let's say, 5 to 6 marks. A lot of people. Verbal is still like people are sort of differentiated. If somebody like really good at verbal, he'll be significantly, ahead. So that's why normalization works in his favor. LRDI also, like, because LRDI is like based on set selection, and one question itself like carries 3 questions to it or 4 questions to it. So you will like basically there also the difference comes, because let's say somebody is not able to hit a set at all, so he'll directly be sort of, when somebody hits it, then they'll directly get like 12 marks out of it or 9 marks out of it. For quant, because every question is independent, and like every question is based on the fact that okay, you may know, but you need to do it in the limited time, right? Because time is of the utmost essence. So there'll be a lot of people in the same range of months. So now what that means is basically if you leave a sitter, it might cost you quite a bit. Like if you come outside thinking that okay, no, this was an easy question, or you suddenly you strike the concept behind that after coming out of the exam, then it will be like a lot of regret. And I have faced that firsthand, so I'm telling you that. I gave CAT in 2017. There used to be 34 questions there at that time for QA. Okay, and the moment I stepped out of the examination hall, I realized that one small thing, there was a catch in one of the questions, and it struck me, and it's not a good feeling at all. Because for quant, you know that every question that you miss, even on knowing, that's a, that does reflect on your percentile. Not like very highly, but yeah, that does reflect, especially in quant where the competition is quite a bit. So yeah, so in terms of relative marking, in absolute marks, it may only like harm you by 3 marks or stuff, but relative marking, it will push you quite a bit. So there were 34 questions at my time, and at attempted 32, which was 30 C and 1 and 2 wrong, which were both unfortunately negative. So the score was 88 there. But yeah, but that was still the difference, right? So even in that year, like, or in every year basically, there'll be a range. So for example, in that year, the range for 75 to 8, or let's say 70 to 75, would have been pretty tight, like thousands of people here. So if you just slip in a bit here, the percentile would be like obviously better. So people who scored higher than me would obviously maybe would have had more knowledge, but also it could have been a case that they would have had same knowledge, but just there they would have been able to strike certain things in that exam anxiety. So the difference is not knowledge most of the times, at least for like a similar range of marks. And geometry, especially, people tend to run away. So like I can personally assure you, if you do geometry right, the percentile automatically shoots up. Like in your, like for example, nowadays questions I think in quant range from 20 to 24. It varies. Like nobody knows till actually the paper comes. But let's say if they're 24, you can expect around 4 to 5 questions from geometry. Even let's say if it's four questions mean 12 marks. If you're able to hit 9 out of it, the average janta in a CAT geometry paper will be able to not hit more than 6. Like the average person appearing for the exam, maybe even like a lot of them maybe even at 0 or 3. And this is important to know so that your preparation can be tailored towards the fact that how every question can incrementally make a real difference. Because quant, even normalization doesn't help as much. Because people are very closely spaced in terms of score. Verbal and LRDI, it's proper capitalism. If you have scored well, the normalization will push you even ahead. But that liberty isn't available for quant. So quant, you'll have to, like, the raw score itself should be significantly uh, good. So that is how like each question can make a difference. Geometry and arithmetic people tend to sort of like develop some level of resistance or something. Especially like for arithmetic, there's a long time speed distance question. There's a long mixed allocation question, and yeah, people are likely to sort of get it wrong, even though it might not be a complex question. Obviously, a lot of people would get it right, but a lot of the chunk of the people would not attempt that because yeah, there's an internal lesson that comes. Obviously, if it's taking time, you should definitely skip it. Question selection is the number one rule. And there's one question remaining in this list for today, but yeah, just wanted to have this quick chat so that from like the exam implications of what we are doing is clear, right? So yeah, so like every question, especially from these topics, number system people will solve. Number system is probably the most overhyped topic in the whole of quant. People spend like weeks and weeks to prepare for it, or even months in some cases, and like still like there's only like two questions that come from number system. So you need to analyze things a bit. Obviously, it's important because two question also is like 6 marks, or 2 to 3 questions is 6 to 9 marks. So it's important, no doubt, but not proportional to the time that people end up giving to it. Arithmetic will be roughly one third of the paper, roughly, right? So if it's CAT for 2 weeks after today, so arithmetic and geometry should be the two things that you should be definitely brushing up on big time, right? Because uh, algebra as well, obviously algebra is also pretty important because algebra has a number of topics within it: inequalities, functions, linear equations, logarithms, and stuff, right? So like a lot of subtopics. Even arithmetic has a lot of subtopics: time and work, time, speed, distance, mixture allegations, pipes and systems, simple interest, compound interest, etc. So arithmetic, algebra, geometry like comprise the major. So every question that you do will be beneficial for your percentile. So just wanted to have that chat so that you have that in mind when you're preparing for any of these sections. But do definitely don't get obsessed with quant. It's very easy to get pulled into the loop for quant, and pretty sure like Shivam would also have told you this at multiple occasions. But do maintain regular practice of LRDI and VA as well. Like absolutely mandatory. There's no room for compromise here because these sections can take you significantly up or significantly down. Uh, Again, as mentioned, right, that if you score well in LRDI, normalization will help you even further. Verbal ability similar, but verbal ability, the thing is that it's sort of an uncertain section because like even if you're strong, you don't know that okay, that you cannot say for sure that okay, my mock will definitely go very well for verbal. Like for quant, you can say right, okay, my algebra is decently strong, so you should be able to figure out most of it. LRDI also like you practice a lot. At least DI and all you can say, okay, these type of like analytically well practiced enough, so it should be okay. Verbal is still uncertain, but yeah. So cool. Anyways, a brief pep talk. Uh, like do excuse if you already knew a lot of that, but yeah, uh, that is the thing. And so one final question for a day, and it's circles will be wrapped up for now. And there'll be like a small just planning to have a bonus 5 minute section for some concepts that may be helpful in addition to these things. In the following diagram, length of diameter AB is a two-digit integer. Reversing of the digits of AB gives the length of perpendicular chord CD. Uh, the distance of intersection point H to center O is a positive rational number. Remember, rational number so may not be an integer. Find OH. Okay, so this is not given, but it should be actually. This is there, and this is here. A, B, and C, D. So length of diameter. So this is obviously the diameter. So that's why I was able to name it. Length of diameter AB is two-digit integer. We don't know the length. Reversing the digits of AB gives the length of perpendicular chord CD. So this and this are digits reversed. Distance of intersection point H to center O. This is intersection point H to center O. Positive rational number, find OH. So this is what we have to find as well. Cool. So uh, first things first, these chords are perpendicular, which is given. What can I collect from that? That this is a line, this is a perpendicular from center to chord. So this will be half of this. That's sort of, so this will be CD by 2. This will be CD by 2. Right. Distance of intersection, okay, this is a positive number and we need to find that and all. That's okay. Right. Again, immediately what strikes is there are two sort of line segments inside a circle, they are intersecting. Right. So can you use the second theorem? And again, needless to say, second, like the diameter is also a special case, or chord basically, diameter is also a chord only. So the formulas are applicable there. So basically, nothing but AH into BH. And there is a reversing the digits of AB gives the perpendicular chord CD, we'll come to that. But let's at least first collect what all we can figure out. because then once we get to the digits, right, then we'll have to like take, let's say, digits as p and q, and then 10p plus q, 10q plus p, and all of the like variables get increased, right? So let's get to that stage, but at a point where we need to have the minimal amount of calculation, right? So ah into bh will be equal to nothing but cd by 2 into cd by 2, cd square by 4, second theorem. Similarly, if I write it here, this one, right? But would it be beneficial for me to write it here? It would give me like ah into hp, but I don't know either of these. I don't even know the radius of it. So there's no number I can get from it, right? But what I can do is that use this equation and write ah as, I want to finally get something in terms of AB and CD so that I can apply this principle of reversing the digits, right? So what is AB basically? Like what is AH basically? It is AB minus BH, or it is this radius minus OH. Like basically this AH is either AB minus BH, but even this I don't know, or it is AO minus AH, or AO minus OH basically. So let's just try like writing that basically, or to see that AO is nothing but AB by 2. Why? Because this is diameter, this is radius. So AB by 2 minus OH, and BH would be equal to, BH is nothing but, okay, this is actually works out well, because BH is nothing but OB plus OH. So this is AB by 2 plus OH. This is A minus B, A plus B. I can figure it out then, the AB square by 4. And this is to be found, right, OH. So that was the reason why we wrote this in terms of OH. And also, coincidentally, we were able to figure out that this radius is nothing but AB by 2. So basically, this is AB square by 4 minus OH square CD square by 4. So basically nothing but, if we take it to that side, so it will be AB plus CD into AB minus CD equal to 4H OH square, or this should be. Any doubts till this point? Okay, awesome. Just let me repeat one thing for one. The reason we wrote this as into this form. So first of all, like obviously we know that this will strike you immediately. Now we need to find OH, and there's a condition given in terms of AB and CD. I already have CD in the equation, and this can be written in terms of AB and OH. So I just written it that way. So I just sort of looked at the question, what is needed, and what the conditions are given, and just place those variables here. Because otherwise, if I wrote AH as, let's say, something like AB minus BH, BH is neither given nor required. It won't help me. Similarly, like for the other case as well, like let's say the AB is also like the value is not given itself, right? So AB by 2 here and OH. So there's no way to figure out BH as well. So that's why, because it was appearing in this and this, so I wrote in those terms. So this basically gives us that, okay, AB plus CD into AB minus CD by 4 is equal to OH square, right? Now what does this tell me? This is a rational number, it seems. So basically you have some kind of a this thing that OH is root over AB plus CD into AB minus CD upon 2. Now for it to be, okay, no, we have already made the 4 into 2. So for it to be rational, this entire thing should be a perfect square. AB plus CD into AB minus CD should be a perfect square. Correct. Now you basically use, because we don't know any of the lengths, right? We only know that, okay, reversing the digits of one gives the other. So now if we sort of use the fact that AB, let's say, is PQ, so it is 10P plus Q. CD will be QP, which is 10Q plus P. So what will be AB plus CD? So basically AB plus CD into AB minus CD should be a perfect square. AB plus CD is what? 11 times P plus Q. AB minus CD is what? 9 times P plus P minus Q. So essentially this is like 11 into P plus Q, 9 into P minus Q. Right. So how can we make, and this entire thing needs to be a perfect square, right? So that the root is a rational number. How can we make this thing a perfect square? We can make this thing a perfect square basically if like p plus q into p minus q, if p plus q can be somehow like if the product of all these four, it can be somehow a perfect square. So this is 3 square, right? This is 3 square, this is 11. So what we need to do is we need to figure out another 11 from this. We need to just figure out another 11 from this so that the entire product becomes 11 into 11 into 9 into 1. For this to be a perfect square, we can have other cases. For example, you might ask that, okay, but even if you multiply this with like 11 cube, it should also be a perfect square, right? Because the overall expression will then have 11 raised to 4, which is also a perfect square. But do you think that like these are two-digit numbers, right? So two-digit numbers addition and two-digit number subtraction, the product of them will never give a number like 11 cube and stuff, right? So to convert this into a perfect square, what you can do is 111 you already have. 3 square is already perfect square. You don't need to even disturb this. So what you can say is p plus q into p minus q can give me another 11. Can give me another 11 means that p plus q should be 11, p minus q should be 1. Let me repeat it once more time. This number needs to be perfect square, so 11 needs to combine with another 11 or 11 cube or 11 5 or something, or let's say 3 square can also become 3 4 or 3 6 or something. But within the realm of two-digit limits, those high estimates are not feasible because after all p and q are single digits, right? The number is AB length is PQ, but P itself is a single digit, right? Q is a single digit. So you won't have numbers like 81 and all going. So we have a single 11, we need to get another 11. So P plus Q can be made as 11, P minus Q can be made as 1. It directly gives P as 6 and Q as 5. To essentially say that AB would be 65, CD would be 56. Cool. Now put just the OH here basically. So it is AB plus CD, which is 60. So basically, this is AB square minus CB square. This one or the expanded form of that. So this is nothing but root over 9 into 65 and 56 give me 121 by 2. So this is obviously a perfect square, 3 into 11. So 33 by 2, which is 16.5. This is the answer. So pretty good question, combining sort of like some number properties and geometry. But yeah, so just wanted to like, yeah, any questions?
Yeah, actually, I just did Pythagoras theorem and it worked for me.
Awesome. If you could share that method, that would be pretty awesome.
No, I just I have just taken 10a plus b first thing and second thing 10b plus a and just use Pythagoras theorem for that ch and oh and co, and I got that same equation which you got.
Yeah, that also works. Yeah. So like in general, my approach towards like, for example, for like if these type of conditions are given, I have to reduce the number of variables as much as possible. So that is why like my thinking went directly to this. But yeah, very good that you have sort of worked out it via Pythagoras as well by taking that. And geometry again, alternate methods should always be engineering. And we saw there, right, like in one of the questions that it was like the equal tangency rule for this one, right? So this and this equal, this and this equal, this and this equal. Figure out semi-perimeter and stuff. So yeah, it's always good to sort of have that so that we know the application of different concepts on the same setup. But yeah, so this is there. And again, like don't go by theorem names. Some people use some theorem names for something it doesn't. Like for example, the cyclic quadrilateral area formula is called some Brahma-Gupta formula and all, but no need to go by names and all. As long as you know the theorem, it should be okay. For example, there's a funny theorem actually in geometry only called the British flag theorem. Have you guys studied that? So it's for a rectangle basically. The name is funny enough because it resembles a British flag. That's what I would say. It's called the British flag theorem. So this proves that the name of the theorem is not important at all. If you take any point P inside a rectangle, which is ABCD, PA square plus PC square will be equal to PD square plus PB square for a rectangle. This is always true. This is called the British flag theorem. So, but yeah, again, the name shouldn't really matter. So this is true for rectangle as mentioned, and any it works for any point. It works even for outside points, believe it or not. If there is a point here, and you join these points here, even then it will work. PS square plus PC square will be equal to PD square plus PB square. These things, obviously, this doesn't fall into the purview of circles. So, like, haven't covered this. So, so that in terms of like the question coverage, so that was all from a circle standpoint. Uh, and you will see, right? So, just to sort of, since it was a slightly extended session, so just to sort of revisit some of the things. So, this was a CAT 2020 slot 2 question. It's supposed to we have done at the beginning, but anyways, so ABC by 4 into that one, and again area you have to calculate by base into height. That is simpler rather than using distances and then the herons and stuff for the area formula for coordinate geometry. Tangent OA, okay, this was a common setup that we used. Similarity basically, and we just established one relation of similarity, and that was it. Just this small triangle to this big triangle, and from one equation itself, there are no other unknowns. You can figure it out. So 96 by r is 180 by 204, and this should be done. Intersection are two distinct points. So as somebody had rightly pointed out also that these two segments will not be equal, so because the radii are different. So you have to figure out each of them, and by figuring out each of them, I mean that basically that's an equation like in x and y, two equations, two variables, because use height as a common. Sum these up because the sum should be the by the Pythagoras 10 root 3, and you can find out x and y, and after that you can basically then find out anything, right? So you can use Pythagoras to find out this length, double that to find out common chord length. Area also, this angle would be available to you because this you know this, you know this, you even know this, so you can use any ratio to find out that. Then the area of the sector, and then the area of the segment. So this circle gives this segment, this circle gives this segment. You just add them up and do. If the radii have a common as mentioned, then we could have just multiplied by 2. Just simply 2 in center calculations and just adding the radii. Nothing fancy here. Again, based on the equating the heights and creating two variables. Wherein we knew the sum of the variables would be 25. Why 25? Because 15, 20, 25. These three problems are 1 plus 1, 2 plus 1, and 3 plus 1. So, like to the 0.18. And again, in all such questions where a circle is like put in between or among other circles, so you have to make those triangles and then apply either Pythagoras or simple like equilateral properties to that, and it should be done. So like 0.18, 0.25, and 0.16. We also saw one question that was directly asked in CAT 2019 slot 2. On this, then inscribed in this again was based on the common tangency principle and x plus 6, x plus 4 plus 10 square. Simple Pythagoras theorem once you write those sides. So again, a pretty straightforward question there. Good question in terms of the fact that okay, like though it's visible that second rule is getting applied, but yeah, still like even after this point, you don't need to solve the question. Just see that 27 above, there's only one factor of 30, which is 30 itself. So y would be 3, s would be 1. Pretty simple question. Just the circle is the circumcircle of this, so nothing else to be done. Again, like saying simple is in terms of like once you know the solution, then if it's a stress question, like the actual value would be like if you could strike this immediately, like okay, I can draw a circumcircle and just find a circumradius. End of story. This is probably one of the best questions covered today because there were multiple properties, tangent second first on this tangent from T, then second to find like this tangent property gave us this side, this second property gave us this side. This property you could have figured out from cosine rule, no doubt at all. But also similarity was just simple because we figured out that theta, so this is 180 minus theta for cyclic quadrilateral, this also 180 minus theta, so there is inherent similarity here. Number of common tangents covered multiple times today, so should be okay. It was just a diagram basically, right? And then a standard setup of when you're having a chord, having a radius, you're asked to find the length of the chord or the length of the radius based on what's given. just draw a perpendicular and figure out the other side that you need in order to just apply Pythagoras essentially. Here, those things were also at a relation like r plus 1 and r, so it was simpler. Family of circles question, again, similarity should be the first thing you should need to go to in terms of if sides are the variables basically. And here, if you recall that even within some, like once you have those relations, so basically you can use the fact that some distances are known, like not given in the question, but can be figured out from the diagram. So if the radius is given, then you know that this is 2, this is 4, this is 4, this is 8. So you know that this by this would be this by this plus 2, 4, 4, 8 is 18. You can find out this and then you use the Pythagoras to figure out this. There is a specific theorem for this as well, but I'll not mention that because no, that's like it's the wrong approach for this. In terms of, and it is hard to retain in terms of an exam scenario. So let's not go there. Two circles P and Q each of radius. Yeah, so this is the area of overlap. So again, breaking a figure down into first into familiar figures and then also breaking down visually, like doing a small segment so that it's clearer to observe what's happening there. And this was the reversing the digits question, which we just covered basically. And the only principle probably here would have been to make it into a complete square. Otherwise, every step prior to that is essentially like the method works itself, right? From one step to the next. So that is there. So those are the questions. So if you basically keep a small tally of the questions, so till now we've covered 45 questions in the last 3 days. And again, it's not about the number of questions, like that's not like doesn't hold as much meaning if the variety is not covered, or like the main purpose is to cover the variety of questions and to sort of put that into mind as to how to apply a certain concept, which I'm sure you guys would be able to do now. So this is the end of circles. Tomorrow probably we'll just have a 1 hour small session to just discuss a few of the things on coordinate geometry, right? And yeah, so that should be it then. Could have covered the theory today, but no, like it just sort of over absorption can also be a risk. So, but yeah, we'll cover like 4 or 5 questions of coordinate geometry tomorrow, and like cover some of the basic things that you need to know. That should be done in an hour, like half an hour for concepts or 20 minutes for concepts, and the remaining time for questions. And that will be signing off for the geometry workshop. Any questions, thoughts, concerns, feedback, anything? Okay, cool. Sure, so that marks the end of the session. And the recording will be shared as and when it appears. So see you guys tomorrow then. And the timing would be same, probably 5 to 6 will suffice. So 5 to 6 we can just catch up and the coordinate geometry part of it. Thank you so much guys for attending and have a very good evening.